Welcome to the For All e-learning platform. You can join us on our site tefaafrique.com. I'm your presenter by name Clinton Ojong, and today we are going to be dealing with physics with respect to the competitive entrance examinations. So here we have our course outline, which is going to follow this particular pattern. We have a brief introduction, we have what we call prerequisite, we have general outline of the physics syllabus, we have detailed expansion of the physics syllabus. So with our first part, we're going to look at a brief introduction. So in general, physics is one of the subjects which is found in most engineering and medicine related concours or competitive entrance examination, and so must not be taken lightly because it is a rate determining step in most of these competitive entrance examination. So we're going to start with, we're going to continue with the prerequisite. That is what you are supposed to know before you take this course. So in general, we have a general review of mathematical concepts. That's basic knowledge under algebra and manipulation of certain concepts in math. We have basic or background knowledge on O-level physics. We have also a basic knowledge in chemistry, that is atomic structure, bonding, electrolysis, radioactivity, and so on. We have a background knowledge on the environment and daily happenings. So as a general outline of the physics syllabus, we have the notion of units, dimension analysis and errors or uncertainties, mechanics and rotational dynamics, alternating current circuits, geometrical optics and wave motion, field phenomena, thermodynamics, mechanical oscillators, that is simple harmonic and damped motions, current electricity, that is DC circuit analysis, electronics and capacitors, atomic physics, nuclear physics, fluid mechanics, matter, and finally energy resources. So as a detailed outline of the physics concours syllabus, we have mechanics, where we are going to be focused on mainly linear motions, that is motion in one dimensions, as you can see, projectile motion, motion in two dimensions. We also have Newton laws of motion, that's the three laws: work, energy and power, circular motion, and finally we'll end it with rotational dynamics. We have also field phenomena, and under this particular topic, we are going to focus on gravitational field, electric field, capacitors, magnetic field, and finally electromagnetic induction. We have nuclear physics, whereby we are going to be focusing on the nucleus, nuclear stability, mass energy equation, binding energy, radioactive decay and radioactive particle or rays, exponential decay law, application and quality factor. Then finally, we'll end it with nuclear reactors. We also have atomic physics, whereby we're going to be focusing on the atom, energy levels and atomic spectra, photoelectric effect, wave particle duality, X-rays, and lasers. We also have waves and geometrical optics. Here we have a lot of things to talk about as general concepts. We have wave properties and terminologies, superposition theory and the progressive wave equation, stationary waves and sounds, interference and Young's double slit experiment, diffraction, Doppler effect, the electromagnetic spectrum, notion of reflection and refraction, total internal refraction, optical instruments, that is mirrors, lenses, etc., dispersion and colors. Also, we have the notion of thermodynamics, that is thermal physics, where we are going to be focusing on thermometry, calorimetry, heat transfer, laws of thermodynamics, PV diagrams, gas laws, and finally the kinetic theory of gases. We also have matter, whereby we are going to be talking on pressure and density, surface tension, stress, strain, and elasticity, Hooke's law, Young's modulus, work done in stretching a wire. For current electricity, that is DC circuits, we are going to be like talking on basic concepts, resistor networks, whereby we are going to initiate Kirchhoff's rules and other networks theorems, energy and power in DC circuit, potential dividers and potentiometers. We have electronics and capacitors, whereby we are going to focus on the band theory, semiconductors, PN junction, bipolar junction, diode, logic gates, amplifiers, that is non-inverting and inverting amplifiers. We have AC circuits, whereby we're going to be focusing on a brief introduction, resistors, inductors, and capacitors in AC circuits, RLC circuits, and notion of resonance power in AC circuits, notion of quality factor, bandwidth, cutoff frequency, etc., AC oscillations, transformers, rectifications. And finally, we'll end with energy resources, where we'll be talking of notion of energy, some definitions, renewable and non-renewable energy sources, fossil fuels and nuclear fuels, solar, wind, hydroelectrical, biomass, tidal, wave, and geothermal energy. And for the conclusion, say thanks for your keen audience and hope you stay with us for more upcoming videos.